Today's video will explain the common operations associated with classes representing collections. Hello, I'm James Helfrich. When designing a class that works with collections, there are certain operations that the client expects. This video will explain those operations and describe the best way to implement them in a class. Just about every class working with collections needs to provide the client with the ability to insert, remove, and update elements. If one action is present, then all three are as well. It is often the case that an entire suite of operations is needed. For an example, insert, add an element to a collection, and remove an element from a collection. Retrieve an element from the collection with get, and update an existing element in the collection. Locate an element within the collection, determine the number of elements in the collection, and iterate through all the elements in the collection. Every time that your class deals with a collection, you got to ask yourself, do I need every single one of these operations? And the answer almost certainly is yes. Let's look at each of these in turn. First, the most common actions for collections are to add and remove elements. So add a new element to the collection either in the default location or in a specified location. So in the first case here, 1.0, we're going to pick a new element in the collection. And the second one, we're going to specify where it's going to be. Now, if this can be a stack or a queue, then clearly I don't get to specify where it goes because the data structure will take care of it for me. But most of the time, the user gets to specify the location, and then we get to do that with an index or an iterator or some other mechanism. We also want to be able to remove an element from a collection. Now, notice a data flow diagram does not actually take that location and put it into the collection. It just removes the element from the collection. Now, accessing individual elements is the second most common action for collections. So first, we're going to have get. We're going to retrieve a value from the collection, sometimes through specifying the location and sometimes not. For an example, a stack or a queue or a priority queue, we say, get me the next element. We don't get to specify where. Whereas for a vector or an array or a list, we get to specify the specific one we want. For a vector, then we're going to specify it through index. Through a list, we'll specify it through an iterator. We also want to update a given value in the collection. And then finally, we want to find an element. And how do we specify what we found? Either true or false, it exists, or the location. And that location could be an iterator or it could be an index. It really depends upon the nature of your data structure. And finally, commonly, the client needs to know how many elements are in the collection, and you'd be able to iterate through all elements in the collection. And so the size is just going to return the number of elements in the collection, obviously. Now, iterate is different because I need to give the client the ability to be able to find every single element in sequence. And an iterator usually requires 4 different elements in the design pattern. First, where's the beginning element? Second, where's the end element? Third, how do I increment it? And 4, retrieve an element. Now, there's 2 different ways we can retrieve. It could be a straight-on fetch, or it could be an update, depending upon the need of the container. We commonly have to implement the iterator design pattern in a collection to give the client the access they need. And by doing so, we're abstracting away the details of the underlying data structure. So I should be able to change the collection from a linked list to an array of arrays, to a binary search tree, or any one of a variety of different data structures without the client knowing, because the iterator abstracts out that particular design detail. We can learn more about collections in the collections section of the metaphor chapter of the software design textbook.